All right, so today, graphing quadratics in standard form. So our standard form is y equals ax squared plus bx plus c. This is our standard form. We've been looking at that over the last whole unit. Okay, identifying a quadratic's parent function. A parent function is like the most basic form of a quadratic. There is no bx, there is no c. Okay. So if I am going to graph this, I need a couple of things. I need to find the axis of symmetry, the turnaround point. So where's the, if it's, let's see, a U-shaped parabola, the axis of symmetry would start at our vertex, and it's telling us where it is mirroring. So we would take the opposite of B over 2A. We're going to find the vertex using the axis of symmetry. So what we're going to do, we'll write this down and then we'll take action in a second. We'll plug in the axis of symmetry, x, or 4x, to find y. And this will be an ordered pair. So let's go ahead and do our most basic one. So let's start off with this parent function, y equals x squared. Let's identify what's our a, what's our b, what's our c. So we're kind of ignoring the y, so it's x squared. What number is in front of the x squared? 1. There is no x term, so it's 0x, so your b is 0. There is no constant whole number, so your c is also 0. So if I wanted to find my axis of symmetry, where this thing turns around, I would do x equals opposite of b, so opposite of 0 is still 0, over 2 divided by a, which is 1. So it's 0 over 2. 0 divided by anything is 0. That tells us our axis of symmetry, so where the mirror image is happening, is right on this y-axis. Maybe we label this axis of symmetry. I'm going to create an XY table. This is going to allow me to find ordered pairs to graph. Telling you that it turns around when x is 0. So 0 is going to be my middle ordered pair of my 5 that I'm going to graph. So I'm going to find 2 on either side. So think of a number line. What is 2 greater than 0? 1 and 2. 2 less than 0, -1, -2. So all I'm doing is saying, okay, well, when x is -2, what is y? So let's plug in -2 here. What's -2 squared? +4. Then let's plug in -1. What's -1 squared? 1. 0. What's 0 squared? 0. And I will say, write a little note here, this is our vertex. And it's going to be a mirror image. Yep. 1, plug that in. 1 squared, so you'd have y equals 1. Plug in 2. 2 squared, 4. So it is a mirror image. And we already have typed that equation into our calculator. So if we look at the table, it starts at 0, 0. That's where its standard starts. If I scroll up 2, I'm going to cover up this bottom that we don't need. Our table is identical. We just did it by hand. Your calculator will also do it for you. Another thing I want to note here is this was probably the easiest version because we're just plugging in a number and it's squared. There's nothing else in front of the a is 1. So it wasn't too bad to do the table, but I'm okay if you use your calculator. Let's graph these ordered pairs. So this is our y-axis and our x-axis. So the order pair is x, y. So negative 2, 4. Start at 0, 0, go left 2, up 4. So 0, 0 is there. Negative 1, 1. So left 1, up 1. 1, 1, right 1, up 1. 2, 4, right 2, up 4. Do you notice how on either side of my purple line, it's kind of like a reflection? This is a U-shaped thing, so I'm going to connect these, and I'm going to go past my last dots and write arrows, showing that it's going to go up and out forever. So now that we've seen our parent function, and maybe even right here, parabola, so we have not written that vocabulary word down yet. Vertex, we can even write an arrow to that. Is that our maximum or a minimum? Minimum, because it's the lowest point. Now that we've seen our parent function, our most basic version, we can see what happens if I were to put a 3 in front of the x squared, or a fraction in front of the x squared. So that's what we're doing now. All these first 3 examples, A, B, and C, there is no x or c, like on D, you have something x plus a constant. That means A, B, and C will all have a vertex of 0, 0, and the most standard version. So, and we could find that every time by saying, okay, this one, A is 3, B is 0, C is 0. So we could find the axis of symmetry, opposite of B, still 0, over 2 divided by 3, or 2 times 3. So 0 divided by anything is still 0. But A, B, and C will always be like that because there is no BX and no C. That tells you the turnaround point is at 0, 0 for all of these. A, B, and C. So we're now going to go ahead and create our table. Knowing that A, B, and C, problem A, problem B, problem C, are all going to be using these 5 starts. So I could do this by hand and plug in negative 2 in for x. So it would be 3 times negative 2 squared. Order of operations says do the exponents first. So what's negative 2 squared? 4, so it'd be 3 times 4, which is 12. I could do that for every single one, but that might be kind of tedious, might be kind of time consuming. Okay, so what we can do is press y equals. We can clear that out, press clear, and type in 3x squared. So 3, then your x button next to the green button, squared, diagonal from your 7. 3x squared. And then press second graph. It'll give us our table. So we got that first one right. Now we can fill in the rest. 3, 0, 3, 12. If we click graph, we can see what our graph should look like. Do we see any big differences from this to the last one? It's skinnier, okay? So hypothesis, if I put a whole number in front of x squared, bigger than 1, my graph gets skinnier. Let's go ahead and graph these points. Negative 2, 12, it's going to go off the graph. Okay. Negative 1, 3, left 1, up 3. Negative 2, 12 would be like way up here, so I am going to note that it would be getting taller here, so I'm not going to keep going wider after that point. I'm going to go a little bit wider, but much taller. And then 1, 3 would be here, and then 2, 12 would be like way up here. do something like that. So yeah, it looks like if my A is bigger than 1, it's narrower or skinnier. So that's what I want you to write up here. We're comparing the A's from our parent function, the most basic. So if A is greater than 1, the graph is narrower or skinnier. So let's look what happens when the A is a half, a fraction. So if A is less than 1, any ideas what we think might happen? It would be what? Wider. Yep. Let's create our table. So in my calculator, I'm going to press y equals. I'm going to clear that one out. 1/2, I'm going to type in as 1 divided by 2. And then the x, and then square it. 1 divided by 2, x squared. So then second graph. So our table is -2, 2. -1/2, so I'm going to put 0.5. You could put 1/2 if you wanted to. 0, 0, 1, 0.5, 2, 2. And let's graph them. So 0, 0 is here. -1 up 1/2. So left 1 up 1/2 would be about there. And I'm going to have mirror image on the other side. 2, 2, right 2 up 2. -2, 2, left 2 up 2. So I can see right now that this is much wider. So I'll draw my arrows and I'm going to go past those points. So yes, it's true that if A is a fraction, so less than 1, the graph is wider. Questions?
How do you know like that x is negative to -1?
How did I pick these 5 numbers?
Yeah.
So I picked those 5 numbers based on knowing that our vertex is at 0, 0. Okay, and if I want 5 points and I know that it is symmetrical on either side, I want to pick some on both sides of 0, 0. So I want to pick numbers on that are bigger than 0, which is 2, and 2 numbers that are smaller than 0. We'll do that again for this last one, and then this 4th one here is one that's a little bit more complex, and I'll show you how to find that table because it does change. Good question. So what do we hypothesize, or what do we think might happen if we have a negative number? So the 2 I know is going to make it skinnier. It's going to make it upside down, like that, like an arch shaped. Okay, because there is no bx or c, I know that the vertex is still at 0, 0. So when I'm picking my 5 ordered pairs, I'm going to have 0, x in the middle. And then -1, -2, 1, 2. Let's plug this into our calculator. So y equals, clear that out, -2. Make sure you use negative and not -2. -2, x squared. Maybe I press graph to look at what's happening. So we're right. Good job. It is upside down. Second graph. -2, -8. -1, -2, 0, 0. 1, -2. 2, -8. Let's plot those points. So 0, 0 is here. I always like to start with that one because my graph is a little bit hard to see where my axes are, so that helps me go back to that point and count. So then we have -1, -2, so left 1, down 2. -2, -8 is going to go just off my graph. I'm missing one more. It's a mirror image. So 1, -2. Write 1 down 2. 2, -8, about there. So about like that.
Say we don't add the arrows at the end, we find wrong.
It's most correct to have the arrows at the end because it does keep going on forever. We're just basically taking a little snapshot of this section of the graph. Okay, so right here it says if A is negative, the graph is, maybe we say flipped, we could say opposite, we could say points down. Maybe you write yourself a little visual aid there. Just want you to go back, be able to go back and look at your notes and say, oh, that one was negative, it should be pointing down. Before you even graph it, you should know which way is it facing. So let's look at this one that is vastly different than our parent function. When we have, our parent function is always going to start at 0, 0, it's going to face up, and it's going to be standard. This one, we have a -6x plus 1. This is going to shift our graph around on the coordinate plane. So let's identify what's our A, what's our B, what's our C. What's our A? 1. What's our B? -6. C? 1. So to find the axis of symmetry, we'll do x equals -b over 2a. So opposite of b, what's the opposite of -6? +6. Over 2 times a, our a is 1. So opposite of b over 2a. Simplifying, so this is 6 over 2, which is 3. So our axis of symmetry is the line x equals 3. So what does that look like? If our line is here, so our origin is right here, x equals 3 is 3 to the right, 1, 2, 3. So it would be this line here. This is the line that will have a mirror image on either side with our parabola. That tells me when I create my XY table, x's 3 will be in the middle because that's the turnaround point. I want to find points on either side. So what is one number lower than 3? 2. A number lower than that? 1. Okay, a number higher than 3? 4. A number higher than that? 5. So the axis of symmetry just helped me determine what numbers to put on my table. Now I could plug 3 in by hand and say, okay, 3 squared is 9, minus 6 times 3, well, that's -18. So 9 minus 18 plus 1, what's that? 9 minus 18 is -9, plus 1, -8. Now I could do that for each one, just might take extra time. Or I could put it in my calculator and find my table. So y equals, clear that out, x squared minus, don't use negative, minus 6x plus 1. Second graph. Gives you your table. Now we're shifted up because we were looking up here. We want to look closer to where the 3 is in the middle. Notice on the either side of 3 we have -8 here, and then we have mirroring on each side of it. So let's fill in our table. So 1, -4, 2, -7, 3, -8, 4, -7, 5, -4. Any questions on why we chose these numbers for our x? Now, if I asked you what your vertex was, this middle ordered pair is your vertex. I know that because that was our axis of symmetry x value. And what did we say up here? Plug in the axis of symmetry x to find our y of our vertex.
Doesn't the X and Y on your vertex
Have to be the same thing? No. That was special cases on the last examples. It was 0, 0 because it was the most basic form of these. Okay, so let's go ahead and graph these now. So 3, negative 8. So right to 3, down 8. Again, it's going to go just barely off the graph. So I'm just going to eyeball it. 2, 7. So right 2, 2, negative 7. Right 2, down 7 would be about here. 1, negative 4. Right 1, down 4. Here. 4, negative 7. Right 4, down 7's here. 5, negative 4 is here. Now, am I going to connect these just like this and stop? Nope. Keep going. And give yourself some arrows. You don't need to draw it like through the entire graph. You just need to go past your 5 points and draw arrows. That's showing that I'm looking at this snapshot of our parabola. So here's a part of it. But here's the most important part. If we found the even, so if we kept going, we could find even more important parts, which is the x-intercept, or where it hits our y-axis, y-intercept. Questions on graphing these? Okay, in this next section, we are going to find 3 key features. We've already practiced finding 2 of them. We want to find the vertex, the axis of symmetry, and the y-intercept. So let's start always out by saying, okay, A equals B equals C equals. What's our A? Negative 1. What's our B? 6. What's our C? 4. So I'm going to zoom back out a little bit. I'm going to find axis of symmetry first. So that's going to be x equals something. I'm going to do my work next to it here so I don't get them kind of mixed up. So that's, maybe I'll even write here, x equals negative b over 2a. And we kind of say that as like opposite of b over 2a. So let's plug into that formula. Opposite of b, so the opposite of 6, negative 6. Over 2 times a is negative 1. So that's negative 6 over negative 3. What is negative 6 divided by negative 3? Positive 2. So our axis...
You got that wrong.
Ooh! Okay, 2 times negative 1 is negative 2. Negative 6 divided by negative 2 is positive 3. So our axis of symmetry is... Tanner?
3.
X equals 3. Okay, we're comfortable finding that. Now to find our vertex. Vertex is going to be an ordered pair. We plug in, so it's 3 is our x value of the vertex because it is the axis of symmetry. We plug in 3 in for x, so negative, and then 3 squared, plus 6 times 3 plus 4. So what is 3 squared? 9, so we have negative and then the 9. Okay, 6 times 3 is 18 plus 4. So now this negative was outside, so it didn't go with the 3, so it still is negative. Negative 9 plus 18 plus 4. 13. So our vertex is 3, 13. And you could have plugged that whole thing into your calculator, making sure you use parentheses everywhere you see mine. Last piece here is your Y-intercept. So this is where it hits the Y-axis. Anywhere it hits the Y-axis, your X, left and right, would be 0. So 0, something. What are we going to do? Write yourself this little note. To find Y-intercept, let X be 0. And we did this all the way back in Unit 2. We found Y-intercepts. We took our equation. They were linear equations at this time. And everywhere we saw an X, we plugged in 0. So this looked like negative 0 squared plus 6 times 0 plus 4. What's that? That would just equal 4, yeah, because 0 squared is 0, so negative 0, still 0. 6 times 0 is 0, so we just have plus 4. So our Y-intercept is 0, 4. Let's do another one. This one's going to have fractions. I want you to leave it in terms of fractions because it'll be a repeating decimal, and it's just good to be able to see fractions and not panic. All right, so in our calculator, remember, if I had something like, I'm going to go ahead and create a fraction. So I press second quit. If I did like 1 divided by 3, and I get 0.3, if I want to put that back in a fraction formation, then I would press math right here, and then fraction option, so enter, enter. So to get me back to a fraction. You probably will need to use that.
I just go to math and then num and then scroll up 1 and then it says end and then just click that and then type in my fraction.
That's another way. Okay, so let's repeat those steps. So math, arrow over to num, scroll up, so n over d, and you can type in your own fraction. Another way to do that would be alpha, the green button, y equals, enter. Okay, so there's a couple different ways to tackle that. So let's go ahead and look at this one. First step, identify what's our A, what's our B, what's our C. What's our A? 3. What's our B? What's our C? Okay, so let's find axis of symmetry. X equals something. So X equals opposite of B. B is negative 10. Opposite of that, positive 10. Over 2 times A, which is 3. So this is 10 over 6. Can we reduce that?
Yes.
Yes. Divide the top and bottom by 2. So it's 5 thirds. So that's like 1.6 repeating. I don't want decimals if they're repeating. Okay. So 5 thirds, our axis of symmetry is 5 thirds. That means our vertex is 5 thirds, comma, something. Bless you. So now that means if I plug in 5 thirds, everywhere I see an X, I could find my answer. So I have 3 times 5 thirds squared minus 10 times 5 thirds minus 8. Now, I'm not going to make you do all that by hand because that's going to get pretty hairy. I recommend you type that into your calculator. So notice everywhere I have parentheses, I will be putting parentheses in my calculator. So 3 parentheses, 5 thirds, 5 divided by 3. Minus 10, parentheses, 5 divided by 3. Close parentheses. Your parentheses are above the 8 and 9. Minus 8. Negative 19.6 repeating. I want a fraction. So, math. Enter, enter. Something went wrong. What did I forget? To square it, guys. Yep. So I forgot to square mine. Ooh. So it actually should be negative 16.3 repeating. If you squared it like the equation says to, then math, enter, enter, negative 49 over 3. That's the correct answer. So that's just a good example of making sure we take our time and plug in exactly what's on the paper. It's okay to make mistakes as long as we can go back and analyze them and fix them. So negative 49 over 3. Our last piece is finding the y-intercept. I know it will be 0, comma, something. So if I plug in 0, it's 3 times 0 squared minus 10 times 0 minus 8. It'd be negative 8 because these cancel, it's minus 8, which is negative 8. Questions?
Isn't how we would do it where the last number in the equation is the
Yep. Yeah, and so that's a good point. So the last number in the equation, the constant, will probably be your y-intercept. So was there a constant in these? No. So it was 0. So that's why our origin, or our vertex, is also our y-intercept, 0, 0. Let's flip it over. This next section is fast. It is determine whether the function has a max or min. State the max or min. What I want you to do is find the vertex, basically, and state, is that a max or min? So let's look. This negative in front, is that going to make it a U shape or arch? Arch shaped. It's going to be flipped, right? So this is the vertex. Is that a max or a min? Max. So we might want to say this negative makes it go downwards, and will give us a max. So we want to find the axis of symmetry in order to then find our vertex. So it's opposite of B over 2A. So what's the opposite of our B?
4.
Positive 4, because it's negative, over 2 divided by A, which is negative 2. So this is 4 over negative 4, which is negative 1. So our vertex, negative 1 comma something, and this is going to be a max. How do I find the y portion?
plug in x with negative 1.
Yep, plug right here for x, plug in negative 1. So negative 2 times negative 1 squared minus 4 times negative 1 plus 6. So negative 1 squared is 1. Negative 2 times negative 1 is, negative 2 times positive 1 is negative 2. Negative 4 times negative 1 is positive 4 plus 6. What's negative 2 plus 4 plus 6? 8. Could I have plugged this entire step into my calculator? Sure. Sure could have. So vertex is negative 1, 8. B. Don't let these f of x fool you. It's the same thing as y. It's just function notation. So in front of here is positive. So that tells us it's going to be upwards, so a U-shaped. And our vertex, the turnaround point, is going to be a minimum. So x equals opposite of b. Our b is 8, so opposite of 8 is negative 8. Over 2 divided by a, our a is 1. So negative 8 divided by 2, negative 4. So our vertex is negative 4 comma something, and it is a minimum. Let's plug in negative 4. So negative 4 squared plus 8 times negative 4 plus 7. Plug that whole thing into your calculator. Use parentheses. Riley, what'd you get? Negative 9. Very good. If you didn't get negative 9, you probably forgot parentheses. Maybe you even did what I did on last time and forgot your squared. Questions? Okay, that's it for the new stuff. We have 2 things to review. Finding the zeros or roots of a quadratic equation. So, aka I'm asking you to solve. Solve. What are the, let's go with 4 ways to solve a quadratic equation. Square roots.
Quadratic formula.
Quad formula.
Factor.
So the x factor.
GCF.
GCF. There's one more, which I told you I would teach again this unit. Complete the square. I'm not going to write it down because that's what we're going to really do next class. Okay? So we have options, right? This first one, don't let the f of x fool you. It's just like a y. Or we've seen it as 0 equals x squared minus 4. Just 2 easy ways to solve this. One is easier, or one's faster than the other. Okay? The one way would be to take each of these, square root them, so it would be x plus 2, x minus 2. An even faster way, because then we have to set each of those equal to 0, right, and solve. An even faster way is to get the 4 to the other side. So inverse is adding 4, so 4 equals x squared. Then, similar method, square root. So the square root of x squared is x. Square root of 4 is 2. Could be positive 2, could be negative 2. I know you guys would rather, most of you like to see your answers this way, with x on the left. Either way is fine writing it. Remember, this is where your parabola hits the x-axis. Last one. I know this is a big day. Questions on 4A? Okay, our last one. Is this one ready to go?
Yes.
Ooh, no.
6 to the other side.
6. Kick it over. It's positive, so you're correct. Subtract.
Negative
0 equals x squared plus 3x. We're combining these. Negative 4 minus 6 is negative 10. We could use the quadratic formula. Or we could use the x if it works. So at the top, a times c. So 1 times negative 10, negative 10. At the bottom, b, 3. Do we know 2 numbers that multiply negative 10 add to 3?
Negative 5 and 2.
No,
Negative
negative 2.
2.
5 negative. Oh.
Okay, so if I just hear my first answer I heard, negative 5 and 2. Yes, they multiply negative 10, but do they add?
No.
No, so let's flip and make the negative on the other side. Again, it's okay to make mistakes as long as we reanalyze, right? Can I use my shortcut? Yes, why? Just because we said so. Because my first term is 1. Would you guys like to see me do it all the way out or use the shortcut?
Shortcut.
Okay. So if I did it all the way out, then I would split the b term with those two factors, but we'll do our shortcut. So it's positive 5, so x plus 5. Negative 2, so x minus 2. All this is set equal to 0. If I said factor, you'd be done. However, I said solve. So we're going to take each of these, set them equal to 0. X minus 2 equals 0. And solve. Subtract 5. X equals negative 5. Add 2. X equals positive 2.